Okay, so last class we talked about evaluating logarithms, okay, and then we talked about how to write logarithms, how to switch back and forth between our two forms. So we have exponential form, we have logarithmic form, and we have to know how to go back and forth between the two, okay? We're going to put that on pause because that is important, but now what we're throwing in with 5.2 is going to be our properties of logarithms, okay? There are 3 properties that we need to know like the back of our hand, okay? And I think that they're going to click for you today. I know they will, as long as we pay attention, take our AirPods out, and put our phones away. So once we get these 3 properties down, then this should be pretty straightforward from there, okay? So the properties that we have, can't talk, are these 3 right here, okay? So the first one is the product rule, okay? And when I say product, what math word automatically comes to your mind? Multiplication, okay? So multiplication is interchangeable with addition, okay? So those of us who love to draw hearts and little things on our notes, today's your day, okay? Because multiplication and addition are going to go together. That's what the product rule states, okay? These 2 are interchangeable. Then we have the quotient rule. And what math word comes to mind when we think quotient? Division, okay? And division is going to go with subtraction. I'm just abbreviating because I don't want to write out a bunch of big words, okay? And then the last rule is called the power rule, okay? And this one's not quite as mushy-gushy here, but basically what this one states is that powers with logarithms can be written on the back, like we typically see powers written, okay? Or you can move them to the front of the log, okay? Either way, they are interchangeable, okay? So product means multiplication goes with addition. Quotient means division goes with subtraction. Power rule means powers can be on the back or the front, not both, one or the other. But those are my 3 rules, okay? So we're going to be using these rules to do what we call expanding and condensing, okay? What does the word expand mean? Yeah, make bigger, make larger. What does condense mean? Make smaller. That's exactly what these processes are going to do as well, okay? So, first rule we're going to work with is product rule, which once again, multiplication goes with addition. Okay, so when I'm expanding, okay, I'm going to see one logarithm written, okay? And then I'm going to see on the inside, something's going to be going on. So in this case, do you see how that 5 and that y are being multiplied, right? Okay. And multiplication is going to get split up with addition. Okay. So how that's going to look is log base 6 is going to stay. Okay. That's going to be my base for this whole problem. Log base 6 of 5 plus log base 6 of y is how I would split that up, okay? So the 5 and the y were being multiplied. I split them up with addition, and once again, both of them keep log base 6, okay? Because that's the log and the base that I'm dealing with. So that's how I expand. Any questions there? Okay, condensing then is going the reverse direction, okay? Making it smaller. So I notice here I have 2 logarithms, okay? Do they both have the same base? That's important, okay? That means I can do this problem, okay? So I have 2 logarithms. I'm condensing them to 1. Okay, log base 3, yep. And then 10 times x, because once again, addition and multiplication go together. So when I'm condensing, instead of breaking them apart with addition, I'm putting them back together with multiplication. Okay, does that make sense? All right, there are 2 examples right below this box. Those are for you, so go try those. And the blank that's right here just says that the bases have to be the same, which we already talked about. Okay, log base 2 of 3 log base 2 of 3 plus log base 2 of a. Okay, if you put parentheses, great. If you didn't, I really don't care. Okay, they don't really mean a whole lot with this one. But that is how we expand. Any questions there? No? Okay, condensing. Somebody else. How'd you do this one?
Log base 5.
Good.
2
Of what? 2y times 8, which would be 16y. Okay, because we're multiplying. So 2y times 8 would be 16y. Okay. Any questions there? We're golden? We're good? Girls, we're good? Okay. All right, moving right along. Next up, we have quotient property. Okay, so same thing. We're going to expand and then we're going to condense. So expanding. We look, okay? We notice on the inside we are dividing, which means subtraction, right? Dividing and subtraction go together. So we split this up. We expand it as log base 7 of a minus log base 7 of 2. Okay, always go in order. So the top goes first, the bottom goes second. Okay, and then we got condensing, which once again is going the opposite direction. So one thing though I forgot to do is fix this typo. So please forgive me. Real quick, change that to subtraction. That was supposed to be a subtraction sign. Okay, so now we know that we have log base 3, so we can condense these. And then I'm going to have what? Yep, x cubed over y. Good, because once again, we switched that to subtraction, which goes with division. Okay, cool. So that is my answer. Any questions there? Okay, those two right there for you. Go try them. Okay, expanding. This one, what'd you do?
log b parentheses 4 minus log b parentheses 6. And subtraction.
Good deal. Okay, Henry is correct. That's how we do that. Okay, if you didn't put parentheses, not a huge deal. And then condensing. Somebody else. Yep.
Log base 5 parentheses
3z divided by 8. You got it. That is it. Okay, Connor is correct. So, any questions there? Could I simplify that? 3z over 8? No, I can't, but at least I checked because sometimes you can. Okay. What? If the 8 had a z, then yeah, we would simplify that. Okay, good question. Yes, Connor?
If the creation variable, do you have to put in the 10, or do we just leave the quotient?
You can leave it blank. Yep. Okay, if it's an invisible 10, you don't have to write it. You can if you want to, but you really don't need to. Good question. Okay, last property that we got power property. Okay, here's the deal with power property. When we are expanding, we want the power to be in the front. Okay, so how we would write this would be 4 log base a of x. Okay, nothing else moves besides the power. The base stays where it is. The a value stays where it is. Okay, just the exponent that's on that a value moves to the front. Okay, and then condensing is going the reverse direction. So instead of having the power on the front, we want it on the back. Okay, and once again, it just goes to that a value. So log base 5 of 2 to the 4th would be how I wrote that. Okay, the one thing about condensing though, okay, is if we can make it easier on ourselves, if we can simplify. Okay, so once again, if we can make it easier on ourselves, we want to do that with condensing. Okay, so if there's any evaluating that can be done, like for instance right here, do I know what 2 to the 4th power is, or can I find it? Yeah, what is it? 16, okay? So I can make this a lot easier on myself, a lot more simple by just writing log base 5 of 16, and then that would be my answer there, okay? So once again, that goes for condensing. If you can evaluate, do it, okay? You won't always be able to, but sometimes you can. All right, the two below there are for you. Go try them. Okay, expanding. What'd you do? 5 log base 7 of x. Good deal. Okay, and then condensing, somebody else help me out. Log base 4 of x to the 6th. You got it. Okay. Can I evaluate x to the 6th? No. Okay. There's no way to evaluate that, so I just leave it. Okay. Any questions there? All right. Throwing it all together. Okay. That's what's coming next. So, once again, as long as we know these rules and we know them well, this really should not be too challenging. Okay. Once again, my rules are product rule, which means multiplication goes with addition, okay? Quotient rule, which means that division goes with subtraction, and then the power rule means powers can go in the front or the back, okay? So those are my 3 rules, okay? Any other rules that are in this are going to be rules that you're expected to know from math in previous months or years, okay? So one thing I want to point out in the beginning, just because people tend to freak out when they see this, okay? The first thing you're going to do is you're going to change roots to exponents. Once again, do that first, okay? So change roots to exponents first. This is something we're expected to know back from a previous unit last semester, okay? We did do this. So we'll go over here. We'll real quick write some examples. If I had the square root of x, that would be the same thing as x to what power? Not the second. Nope. That's x squared. So whenever we did this, we took, how we found the power was we took the exponent that it currently has underneath of the root, which is an invisible 1, over the index power, which on a square root would be an invisible 2, so this would just be the 1/2 power. Okay, that would be how I write a square root as a power. Okay, so then a cube root, so a cube root of x would be x to the 3rd. Okay, what about the cube root of x squared? What would that be? Yep, x to the 2/3. Okay, so you get the picture. Once again, this was something we covered a couple months ago, back in like October. Okay, so you are expected to know that. Always do it first, okay? Because once I've changed those roots to exponents, then that follows one of my rules, right? So then I can work with it, okay? So first thing we're going to do on number 1 is we're going to rewrite it because I see a root that I don't like. So I write log. What's my base on this one? Invisible 10. I don't need to write that, okay? So just leave it off. It looks like on top I have x to the 9th times z to the 1/2. Good, because it's square root of z. And then on bottom I have w to the 6th, y to the 4th. So that is now the problem I'm dealing with. Okay, I got rid of that root, so now I know how to deal with this. So we are expanding this, which means we are making it bigger. Okay, we are breaking it apart as far as it will go. So when you look at the inside here, what is the first thing that just really jumps out at you? What do you got going on here? You got division. This is a big giant fraction. Okay, so that is always going to be what you tackle first. If you've got a big fraction, you're going to take care of that first. Okay, so division gets separated with subtraction. So what I'm going to have here when I go to break this up in the beginning is I'm going to have log of the top minus log of the bottom. Perfect. I just wrote the wrong exponent there, didn't I? That was a 9. Okay. Then we just work from left to right. Okay, now that we broke up that fraction, we're good to just go ahead and tackle this thing from left to right. Okay, so moving from left to right, this very first piece, what's going on the inside here? Multiplication, because they're being written right next to each other. That is implying that these are being multiplied, okay? And how do I break apart multiplication? Adding. So I'm going to break these apart as log x to the 9th plus log z to the 1/2. And once again, I'm working from left to right, so I'll keep that subtraction sign. Now I'm going to that second piece there. That kind of looks like the same as the first, right? It's being multiplied. So we're going to split that up with addition. Good. Okay, what did I put here, though, that maybe you didn't put? Parentheses. And why do you think I did that? Why did I put parentheses right there? Yeah, this whole piece is getting subtracted right here, okay? So that means that that subtraction sign has to go to the entire piece, even if I break it apart, okay? This whole thing was on the bottom of that fraction, right? So if I don't distribute that subtraction sign to both of these pieces, what you're telling me is that this first piece is the only one that was on the bottom, and then this one was on the top, okay? Which we know it wasn't. So that is why we've got to make sure we use those parentheses. So just like in all rules of math, if there's a negative in front of parentheses, that means to distribute it. So we're going to do that. Just distribute it to the front. So now I just have log x to the 9th plus log z to the 1/2 minus log w 6th minus log y to the 4th. Okay. You all right with me so far? Okay. So then, once again, we are expanding. If you need to go back and look, okay, what do the powers need to do for expanding? They got to be in the front. Okay, so that is my final step here. I just need to move the powers to the front, and then I'm done. So this first piece becomes just 9 log x plus what? 1/2 log z minus 6 log w minus, and that is my answer, folks. Voila. Okay. What questions do you have? I know this stuff is weird. You've never seen math look like this before. Nothing? Okay. Number 2 is a very similar problem. In fact, it's a little bit easier. Instead of log, though, it says ln, which stands for natural log, right? Do you think that the rules change any for this? No. Okay, so I want you to go ahead and try number 2 using number 1 as an example. Okay, I'll give you a couple minutes here. Work with the people around you. Okay, what's the first thing that's got to be tackled here? The division. Okay, and what do we need to do with it? Turn it into subtraction. So how'd you do that?
ln 3 minus ln 2x.
Perfect. Okay, from there, we're just working left to right, correct? So natural log of 3, is that fully expanded? Yeah, I can't do anything with that. So I'll leave it. I'll keep my subtraction sign. And then what about that second piece there?
Can't you separate it into negative ln 2x minus ln y squared?
Okay, so you're a little bit ahead of me. So that is being multiplied, right? Everything in here is being multiplied, which means I need to split it up with addition, okay? But the whole piece here is being subtracted, which means I wrote them up there, parentheses, right? You with me? Okay, so on the inside then I'd have natural log of 2 plus natural log of x plus natural log of y squared. Are we all good with that step? So just breaking apart that multiplication into addition, okay? But we need parentheses around it because it's the whole second piece getting subtracted, okay? Now what? Now what? Distribute. Good. Negative sign's got to be distributed to all the pieces on the inside. And am I done? Not quite. What else?
You can move the square.
Yep, so only one piece has an exponent, right? And the exponents have to move to the front. So natural log of 3 minus natural log of 2 minus natural log of x minus 2 natural log of y. That's all I can do. Okay, any questions there? How did we do? We either did well or we know what we did wrong. All right, last expanding one that we got, okay? What do you see there that we can't have? The root, okay? We got to get rid of that very first thing. So, I'm going to rewrite this. Okay, log base 9 as c to the 7th, d to the 6th to what power? What'd you say? In here. 1/3, good. The cube root is the 1/3 power, okay? And then here we have another math rule that we're expected to know from like pre-algebra, algebra 1, okay? When we have powers being raised to another power, what do you do with them? Power to a power rule is what this is called. What do we do with powers being raised to a power? Multiply them. Okay, so what this is going to become then is log base 9 of c to the 7 times 1/3, which is, what is 7 times 1/3? 7/3. And then d to the 6 times 1/3. Yeah, 6/3, which is just 2. Perfect. Okay, from there, I'm going to give you about a minute. Expand that. Expand that, expand that. That one should be really easy now that we just got the hard part out of the way. Okay, what'd you do first? What's happening here?
The C and D are multiplying.
Yeah, which means what?
Separate them.
Separate them with
Addition.
addition. So we should have done log base 9 of c to the 7/3 plus log base 9 of d squared. Am I done? No? What's the last step here? Powers to the front. Powers to the front. Okay, so 7/3 log base 9 of c plus,
2 log base 9.
you got it. That's it. That's my answer. That's as far as it will go. Okay, what questions do you have? Yes,
So if you have a power in the front and a power in the back,
you won't.
what if it was two different equations? One equation had a power in the front, the other had.
It would depend on if you're expanding or condensing. Because when we're expanding, they go in the front, and when we're condensing, they're going to go in the back, which we're about to talk about. Okay, so with expanding, there was really no rule as far as like how many logs are going to be in your answer, right? Okay, because if we look, like the first two both had 4, but the last one only had 2, okay? We just know that typically with expanding, there's going to be multiple logs in my answer, right? Just depending on the problem that I get, okay? What was typically the last step for expanding? Exponents, and they went to the front, okay? So every single problem that we did, that was our very last thing that we did, was move the exponents to the front when we expanded, okay? Condensing is the completely inverse process of expanding, okay? So if moving the powers to the front was the last step with expanding, when do you think that step comes with condensing? First, and instead of moving the powers to the front, we move them to the back, okay? So that is a rule that we might want to write down. That might just help us, okay? So when condensing, move the powers to the back first. That's our first step, okay? Another thing that's cool about condensing, so like if I followed the expanding process backwards, which once again is exactly what condensing is, How many logs do you think are going to always be in my answer? One. Okay, every single one of those problems, if I follow it backwards, it's got one log. So, condensing. So once again, when condensing, I need one log, just one, in my answer. So if you still have multiple, you haven't gone as far as you need to go, okay? Got to keep going until you just have one log in your answer. Okay, so knowing what we know now about condensing, moving powers to the back, okay? We know that addition goes with multiplication, and we know that subtraction goes with division. If we know that stuff, we're going to be golden, okay? So, looking at this problem, I first move the powers to the back, okay? So, this becomes log base 4 of 8 to the third minus log base 4 of 2 to the fifth. Perfect, okay? And once again, with condensing, we're making it as small as we can. If we can evaluate, don't we want to do that? Yeah, you can save it for the end, but I'd recommend just doing it as soon as you see it, okay? What I mean by that is, do I know what 8 to the third is? Or can I find that pretty easy? Yeah, go quickly do that. Same thing with 2 to the fifth. What is 8 to the third? 512. And what is 2 to the fifth? 32. Am I done yet, though? Not quite. What do I still have left that can't be there? Subtraction, which means what? Divide. What am I dividing? Keep my log in my base, but what am I dividing? 512 divided by 32. We always keep them in order. And can I figure out what that is, probably? What is 512 divided by 32? 16. So would you agree that my answer is just log base 4 of 16? And I'll stop there. Perfect. My answer has one log, right? Which is what I wanted, okay? So I'm good to go ahead and move on. Any questions? Okay. All right, I want you to try number 2. Just give it a go, okay? Knowing what we know about condensing. So, give you a minute or so. Get started on it at least. Okay, when condensing, what goes first? Powers to the back. So what'd you write? Just to the sixth. Yep. Okay. Good. Good, good. So that's step number 1. How many of us at least made it that far? Okay, if not, write it down. Okay, we need to make sure we do that first. Okay? After that, we just work from left to right. So starting with what we see first from left to right. What needs to go first? The adding, and we do that with multiplication. So I'll keep my log, keep my invisible base of 10, and what am I multiplying?
X to the 12 and
Perfect. Now what needs to go? Subtraction with division. So keep my log, keep my invisible base, and what is going to get divided?
X to the 12 and at the bottom, C to the 6 bottom.
Good. Okay, z to the 6 goes on the bottom. If you put parentheses, great. If not, I don't think it really matters that much. But that is my answer there. What questions do you have? That's a test question. I pulled it directly off the test and changed the numbers, so I'd probably star it. Okay, and then the very last one. Give that one a go. We're almost done. We're almost done. What goes first? Powers to the back. So log base 4 of 8 to the plus Then what'd you do? Yeah, evaluate if possible. So this becomes log base 4 of plus log base 4 of 25. And then what? Times them. Log base 4 of, and that's my answer?
Yeah.
Yep, that's it. Okay, questions? Questions? Nothing? Okay, get your homework done. You have almost 25 minutes.